Hello and welcome back to our series where we are using the Penda Health Data to help us get familiar with Introduction to Medical Stats. So now we will continue and just see what the Penda Health team did. So first thing first, after we've opened back to our project, we need to reload the libraries. So I will just reload the libraries. Okay, there we go. Our libraries are reloaded. So here is where we had reached. We'd look at the mean, median, summary, and then we've done some visualization. So if I may just see the visualization we've done last, yeah. So here is where we were last time. So now we will continue and continue looking at visit info data table. So in this case, we can see visit info. This is what we had, and we had the age in years column, and we had cleaned them a little bit. And you can see by converting them from age in years to age in months, we have some NA values over here, which means missing data missing data. So in this case, we normally want to handle our missing data, and it allows us to make proper analysis, and we handle missing data in different ways. So in this case, it was all a matter of creating age categories from the age value. So both age in years and age in months. So we wanted to squish them into categories of 0 to 4 years, 5 to 17, 18 to 59, and then 60 plus. And then they also go further by having another division over here. So you can see this one is a much bigger division, 18 to 59, and this one is more granular. So we have 18 to 39 and 40 to 59. So they are sort of two age categories that they have created, and that's what they will do here. So I'll just come over here and run this code. So we have these categories 1, 2, 3, 4, and here you have 1, 2, 3, 4, 5. So this is a good step for us to prepare our data, so that I'm assuming they will use this in their analysis in different ways. So there are a couple of things that happen here. One is that you can see we have this function called factor, and this is a basic way of us handling categorical variables in R. So if I do class visit info, and then we say age category, so that's what we have. If I run that, you see it's an ordered factor. So it's an ordered categorical variable. If we do 2, and we do that, same thing. So you may think that 0 to 4, in this case, might think it's a numeric variable, but in this case, we want them as factors, because these factors, once they're coded as factors and are ordered, it means that there is some order in this case, or there is some hierarchy as you move from 0 to 4 to 60 plus values. So that's what this factor and ordered encode for in this case. All right, so we've understood that. Then we go to the next line of code. So over here, they do something interesting. We use what we call left join. So what left join does over here, it basically takes two tables, visit info table and retro data table, and then they join them together. So when we say left join, that means that we want to take all the columns within the left table. So in this case, retro data, and then you take columns from the visit info. So you select by visit code, gender, this, and that. So these are the ones which I've created. And then we merge them to this. So in this case, that means that everything within the retro data table will remain. Everything that is in the visit info that is mentioned here should come there. So anything that is not mentioned here should be dropped off. So that's what left join means basically. So basically we have one table, we have the other, we merge them. Everything that is on the left side remains. Everything that is on the right side that is not captured here drops off. So you can familiarize yourself with the left join, right join. So there are different kind of joins, and that's how we merge tables in even in R and in pandas in Python. Yes, so that's how we handle tables. So that's what they do here. They say take the retro data table, take the visit info table, and then left join. So every column here remains. So from visit info, what we want are these columns. Okay. And then they also say that visit number is equals to visit code. All right. So let us run that and see. And they've said that in retro data. So let us look at over here. We have retro data 1469 observation, then 60 variables. So let us run that and then see how that will change. So if I run that, you see now we have 65 variables. So that means we've retained everything from the initial retro data table, and then we've added these columns from the visit info. That's why now we have additional variables. All right, and then lastly, we write to CSV retro data. So we take retro data table here, which now we have created. So if I just click that, so here is retro data. So it has 65 columns. So I'll just move so you can see the number of columns. Okay. So let us, yeah. So let me go to the next section. Yes. So you can see here at the visit info data that we had over here. This section has been added here. So you can see this one, 1, 2, 3, 4, 5 is here. 1, 2, 3, 4, 5. Great. So you can see over here in the code, they said whatever by means here is that we take retro data and visit info data, and then we join them by this visit code. But because visit code is not captured, let me see here, is not captured in the retro data, instead is written visit number, then we provide this. So visit number is equals to visit code. That way they can be able to merge, otherwise they won't merge. And then lastly, we write to CSV the retro data table. So let us run that and see. Okay, so if you see here, it's in the output folder. Come to the output folder. There we go. We have a new data. So let me say view file. Yes. And there we go. We have our new CSV file that we have exported. All right. So now let's continue and see what next to do. So that one is exported there, no problem. So let us see. So next they say we still take retro data, and then we do some couple of let me see what they're doing. So we include age categories and gender, and then age category in years, and then we create a sort of demographic.html file. So some descriptive statistics now is happening here on the demographics area. So let me just push this down. So we have demographics, so I can highlight all of that and just run that piece of code. Yes, and then we have a .html file. Let me open it. You see, you can say view in browser. So there we go. So now you can see the importance of having the age in categories here. So from the age column that we had initially, from the distribution that we had made initially, now we have age in categories, and we can appreciate how it is in this data set. So you can see 0 to 4 is 350, 15 to 17, it's this, 18 to 59. So if you can remember again, in our distribution, we had this sort of by distribution where we saw many people within the pediatric region captured here with 350, 24%. However, we also saw the majority being middle-aged adults, 18 to 59. So this means that our statistics is capturing whatever we saw in our distribution. And also from the data, if you can remember, we saw the distribution that female were more. So that is what is happening over here. So that means everything is great. So let's get back to our code. So this bit of code is about plotting diagnosis. So I'll just highlight it because much of it is cleaning and making sure the words match. So they take the all diagnosis variables, and then yeah, they do that. So let me just highlight this, and then they take it through ggplot, and they create geombars. So we'll probably see them in bars, and then text with the label. They set the y-axis, create the labels, provide a theme and an axis. So let me highlight all of this and then run that piece of code. Okay, so a couple of things have happened. We have our file name saved at output folder. So let us look at our output. All right, so let me just come back. Then our output. So here we have so bar plot. All right, great. So now we have a bar plot of the diagnosis that is happening. So this is a beautiful way of us summarizing the data and seeing what's happening. So here again is where your clinical acumen comes, because we saw two distributions, pediatric and adult. You can appreciate that respiratory conditions are happening the most in this dataset. So I probably could assume that maybe one is contributing more to this kind of distribution of the diagnosis, or they're even coming from both. And you can see more conditions. So you have respiratory, GIT, followed by genitourinary and reproductive. So at least now you can be able to appreciate how your dataset is looking like from the point of diagnosis. Okay, so that's a good way of you picturing what is happening in the data. So number one, we started with the mean, median, and then we did some summary statistics. So that was at the value level for us to see what is happening. Then number two, we did some basic visualization, and we were able to appreciate again what was happening at that level. And then number three is what we are doing now. So we looked at the distribution again in form of numbers, summary table, and now we are seeing it from the perspective of diagnosis. So yeah, so that's a good way of handling data, summarizing data, and that represents our first instance of Introduction to Medical Statistics. I think from there now we can dive deep into complex things, into more distributions, and to see how that works. So until next time, bye bye.